Welcome back to our podcast. Today we have Simon and Tara of Irystec. Simon is the CEO and Tara is the CTO, Chief Technology Officer, and they're involved in an interesting startup that has larger ramifications for society as a whole. They're looking at combining these different aspects of science, an interdisciplinary science approach to create the foundation for a new technological product. And this has implications for society as a whole. Welcome to the podcast, Simon and Tara.
Thank you, James. We're happy to be here.
Good stuff. Now, my first question is around this idea of combining science into a new type of technology. And I imagine that has complexities because we may have different areas of science and we're trying to see if we can combine that and then to roll that out into a technological product, get that into a market, have that education of the market as to what needs to be changed. Now, from your perspective, Simon, you're looking at trying to change the very nature of how people interact with displays and screens. And you're using the science, the physical sciences of how we perceive screens and information and images. Now, what are some of the issues that you're running up against to try and convince people to change their behaviors and the way that we think about the way that humans and computers interact?
All right, James. Yeah, that's basically the big issue that we're dealing with at Irystec, and really the whole technology solution that Irystec is proposing for the display change or revolutionize how we interact or interface to displays was the focus or subject of Tara's thesis. And she's actually the founder of the company. She came up with this whole idea that really what we have to do is understand how our eye behaves and works, and combine the physiology of the eye with image processing, computer vision processing algorithms to address a range of issues that we're facing today with this role that displays play in our lives. We spend 8 hours in front of displays, staring at displays, laptops, mobile phones in particular, and tablets, etc. And there's all sorts of side effects that aren't good. From a health standpoint, of course, eye strain, eye fatigue, headaches, but also in general, there's just a user experience really want to see based on the fact that we don't view these devices like we used to in a living room, as in old-fashioned. We view these devices where the environment changes, and the display really needs to adapt, be smart enough to adapt to the environment, so adapt to the ambient light in which you're viewing them. If you're viewing the display in the dark, versus room lighting versus bright light, and because your eye behaves differently in these different ambient light conditions, it should really be personalized as well. That display and how it's presenting content to you should be personalized to match. For an older person doesn't see contrast nearly as well as a younger person, but why is the same content and display presenting that information to a 20-year-old the same way as it's presenting it to a 6-year-old? It really clearly shouldn't. So the display should be smart enough as well to adapt to the person who's really looking at them, and that really requires, again, this combination of physiology science, of understanding how the eye really behaves, along with the realization or model through image processing to address that perceptual issue.
Simon, and this is a whole emerging field in technology. We are seeing wearable devices. We're seeing computer devices, hearable technology, as it's been coined in the last little while. But all of this rides on the human-machine interface and the ability for us to interact more effectively with computer devices, particularly as we move into more real-time systems and we're trying to interact with more data and we're trying to interact with different kinds of data. So I find it interesting that you're bringing the science into this side. And when we look at the human-machine interaction that you're focused on, which is the visual aspect of it, have you managed to come up with metrics or assessments or evaluation techniques that give us that sense that the science is giving us the ability to see actual improvements in this human-computer interaction?
Yes, absolutely we do. And I'm going to see if bus quality is good enough here to chime in on answering that question. This is a really good question about, do we have, if I understand correctly, a subjective test in this case that shows that this approach we're taking of introducing perceptual processing in display devices and improve this man-machine interface of how we interact with the display. And then is there a way to measure it, to quantify that? So Tara's spent obviously a great deal of time dealing with this and has got the insight information we did. Tara, do you want to comment on that?
It will be my pleasure. So you guys chime in if anything off or it's not good. But yeah, that you're right, James. Of course, in the world of image processing, computer vision for cameras and displays, there are so many available metrics, quality metrics, but most of them controlled quality metrics in controlled conditions. For example, you want to look at an image quality in a very controlled lighting condition. And the challenge with us evangelizing what we are doing today, which is perceptual aspects of displays or the camera industry, is that, as you pointed out, there are not so many metrics. So when we introduce these kind of products, we need to introduce the metrics for them as well. And that is what makes our life a bit harder. It's in the research world, there are universities for the last decade or so, I would say, who are focused on this. Particularly Cambridge University has a very strong research group who are focused on perceptual image processing metrics. And us in Irystec, we collaborate with them very strongly by to come up with different ways of bringing in subjects and end users as the people who are supposed to rank a technology and feel comfortable with it, or if you're talking about really actually end users are the ones who would approve it eventually. So we do a lot of subjective testing and provide that to our class users as metrics.
Tara, when you were mentioning this interdisciplinary approach and how you bring in the expertise of various experts in there, I'm wondering how you managed to construct that, how you managed to bring in the kinds of disciplines that are necessary. Can you first give us a sense of the science disciplines that are mixed together or merged together to form this system of knowledge that you have, as well as give us a sense of how to combine various sciences? What is your methodology to take the various elements from different sciences to bring it into a composite knowledge base that then is turned into a technology?
It's not, well, researchers would admit that even in research world, it's not easy. I think in startup world and business, but I'll just name some of the fields and scientific fields which are involved we need physiologists, psychologists, image processing expert, computer vision, display faculties, and digital signal processing. Those are the fields and expertise that we would need in-house. research side of it. Of course, the engineering side needs quite a diverse knowledge as well. How we put them together, that's, I was doing my PhD in an almost interdisciplinary field. So that was me. I did my PhD in computer vision and image processing with a touch and a part of physiology. So that was the starting point for sure, for me to get introduced to people from both fields. I expanded my network. There were a lot of different events or conferences that I would go to, which were early in my field, but close enough. And then later, when I decided to start Irystec, I got introduced to a fairly great network of investors who would open door and help you get in touch more on the business and market side, to bring in all the cutting edge knowledge into the company as well, and then slowly, like, getting the first maybe one or two experts, as we call them in-house, board members, was very tough. But the moment that you get 2 or 3 very knowledgeable people in different fields, then it's easy to motivate the others, because in the research world, it's also very much interest to work with researchers from different fields that usually in academia you don't get a chance to work with them. But through Irystec, them from 10 different universities, we work with them. They do get a chance to work on interesting projects that are very, and that became an interesting aspect that we helps us attract their attention and their interest into working with Irystec.
Tara, I'd like to cycle back to this idea of metrics and how to evaluate it, because when you were listing the various areas of science, some of them were the cognitive sciences and some of them were the more quantitative sciences. So you've got the qualitative and the quantitative in there. And as Simon mentioned earlier, a big aspect of improving the human-computer interface is that perception side. I'm wondering, in terms of how does this science and technology combined leading to an improvement in the interaction? We can measure this in terms of the effectiveness, we can measure it in terms of power savings, or we can measure it in terms of the brightness of the screen. But how do we measure something that's more subjective, such as that this has created a better environment for the person, or this is more or less harmful, I should say, in a healthy environment? How do we measure that kind of thing?
That is a very good point, and it's challenging. When it's interdisciplinary, it's challenging to measure or have a metric for any interdisciplinary field. The fields of science have their own metrics. For example, if we were just purely talking about a physiological or psychological study, there are a lot of neuroscience kind of studies that they put in place. When we are talking about image processing, we go back to the standard metrics which are out there. But when we are trying to combine those two, it becomes a bit complicated, because none of the metrics to measure the combined research proof of concept or product. So as I mentioned before, we try to collaborate with all the experts in this field and come up with new metrics. One of the things that we do to measure perceivability of images, let's say, is a lot of subjective tests. Psychologists or physiologists, the eye's behavior in different lighting conditions, they used to run a lot of subjective tests. Now we run the on some of the image processing metrics. So it's basically a combination of both fields. We do side-by-side tests a lot, A/B testing. Let's say we have a new technology that makes screens more visible under extreme lighting conditions, under extreme sunlight. What we do, one of the things we do is that we do pairwise comparison subjective tests. So we 50, 60, 100 subjects, and we ask them to compare a display running our technology and a display which is not running our technology, to see which one is more visible. Statistical ways from the number of subjective results that we get, that we can come up with, like, how effective is that 30% better visibility. One of the ways is this, but it gets a bit more complicated. When we're talking about visibility, it's easy. You're big objects, but when it becomes something in the health domain, like less eye fatigue or healthier interaction for the user, then it becomes more complicated. And there are two ways we can prove this. One is to rely on the research from 50, 60 years of research on interactions with different types of screens. We do that right now. So we rely on a lot of studies that researchers and physiologists have done on looking at screens or staring at screens for more than a few hours, how reduced contrast on a screen can affect our eyes' performance, and rely on that. And then by proving the fact that Irystec can increase the kind of perceived quality of the image, we try to kind of marry those fields together. A longer-term plan would be to kinesiological researchers on the new product, which will be out in the market.
Okay, very cool. As we come to the end of our podcast, I was wondering whether you might have any takeaways for our listeners. Seems to me there's a couple of interesting threads that have come out of what we have today, is this idea of the interdisciplinary science approach to development of new technology, this movement in the market towards the integration of people and technology. We're seeing wearables, we're seeing embedded technology, as well as this movement towards making our interaction with technology not just more effective, but more healthy. For the podcast listeners, as takeaways, is there any items that they can act on?
Jump in and suggest a few takeaways for the listeners. Number one is I think be looking for the industry to be addressing these issues, that seeking out technologies like what Irystec is developing, and kind of demanding that they appear in the display device. Ultimately, it's the consumer that really dictates to a large degree what industry does. Certainly in terms of mobile phones that you see adopted in smartphones, but even in cars, car manufacturers respond very much to what they as well hear their buyers, the drivers, and seek out displays that are healthier, that are energies that are better for you, perhaps more power efficient as well, which is another side effect of adoption of perceptual technology like cars. So that would be, my one suggestion. Tara?
It's very much, James very nicely summarized the points that we had in mind, but I would say also on the researchers who are listen to this podcast, or potential entrepreneurs, or the ones who are interested, coming up with technologies which are not only cool technologies, but things which are healthier and would help interactions with the technologies for the future generation. I think that's what today from the whole tech entrepreneurial part of the world. So I would say the box and coming up with maybe first problems that we see in the way we deal with technology today, advantages of it, but each technology which is introduce disadvantages as well, and find just to overcome and compensate for those disadvantages.
Great. Thank you, Simon and Tara, for talking today about the interesting area of combining sciences and technology to come up with healthier products for the future. Thank you very much for joining us. And that's it for our podcast today.